Hi, this is the Amateur Logician. Hopefully you are doing well. Together, let's consider the philosophical puzzle of Theseus. From the outset, I want to note that this is not a scientific question in terms of how we commonly think of what science deals with and what it concerns. This truly is a question for philosophy. It is a philosophical puzzle, and the empirical scientific method will not solve this puzzle. In fact, there's no way it could. This truly is a philosophical, logical puzzle. And logic and philosophy is required in order to solve this puzzle, or at least attempt to solve it. To be sure, in this video we might not solve the puzzle. However, instead I want to emphasize the logic involved. Logic helps us think about relations, and in fact equivalency or identity is a type of relation, where one thing is identical or equivalent to something else. We have numerical identity. For instance, if x is identical to y and y is identical to z, then x is identical to z. This principle we implicitly employ all the time with basic mathematics, with basic high school algebra. That's the transitive principle, or transitivity. And we could express these basic principles of equivalency or identity in terms of predicate logic, where we use quantified variables with the upside down a. For all x, for all y, for all z, if x is equal to y and y is equal to z, then x is equal to z. Now, this very logical principle makes the puzzle actually quite challenging. And we'll see that as we continue. So here we have the ship, the original ship. Let's call that S sub 1. We have the original ship. So S sub 1 is equal to the original ship. Let's say time passes, and some of the planks of that original ship are going bad, so they're replaced with new ones. So new planks are installed to replace old planks going bad. Now let's imagine that every single plank has been replaced with a new plank. So let's say S sub 2 is equal to all new planks. Each and every plank has been replaced with a new one, and we're going to call this ship S sub 2. Now imagine that all those old planks from the original ship have been saved, and then later reassembled to form a ship, and we will label this S sub 3. S sub 3 is the reassembled ship. It has all those old planks. So the question is, what's identical to the original ship? The relation of identity actually makes this tricky, in particular, transitivity of identity. So let's step back and think about the logic of equivalency. Equivalency or identity is a relation, and there are three principles involved. We have reflexivity, where for all x, x is equal to x. That's pretty obvious. So the original ship, S sub 1, is identical to itself. No kidding. Then we have symmetry, that for all x, for all y, if x is equal to y, then y is equal to x. So equivalency upholds reflexivity and symmetry, and also transitivity. Recall, for all x, for all y, for all z, if x is equal to y and y is equal to z, then x is equal to z. Now let's think about that original ship. Obviously, the original ship is identical to itself. But is that original ship identical to S sub 2? Is it identical to S sub 3? Let's think about another example. I have a car. If I have a car and replace a tire, it's still the same car, correct? Most of us would answer obviously yes. So we have the original ship, S sub 1, and it loses a plank and is replaced with a new one. Let's call this S sub 1 prime. Just as if I replace a tire for my car, it's still the same car, just replacing a single plank with a new one seems to suggest that we still have the same ship. Or in other words, S sub 1 is identical to S sub 1 prime. Later, S sub 1 prime loses another plank and is replaced with a new one. So let's call this S sub 1 double prime. Obviously, it seems to reason that just as S sub 1 is identical to S sub 1 prime, that S sub 1 prime is identical to S sub 1 double prime. This is where transitivity comes into play. So since S sub 1 is identical to S sub 1 prime, and S sub 1 prime is identical to S sub 1 double prime, it logically follows by transitivity that S sub 1 is identical to S sub 1 double prime. Now we could imagine S sub 1 double prime being replaced with another plank, and that triple prime being replaced by another plank, quadruple prime, and so forth. Hence, logically, by transitivity, S sub 1 is identical to S sub 1 prime, is identical with S sub 1 double prime, etc., all the way down to S sub 2, where every single plank of S sub 1 has been replaced with new ones. So we seem to have come to the conclusion that S sub 1 is identical to S sub 2, and S sub 2 has all new planks. And we reach this conclusion by transitivity. So it seems that S sub 1 is identical to S sub 2. But what about S sub 3? Prima facie, is not S sub 1 identical to S sub 3? Well, why would that be? Well, because the construction of that ship used all of the parts from the original. Hence, it is the original. So it seems that we should say that S sub 1 is also identical with S sub 3. It is therefore possible to claim that the original ship S sub 1 is identical to both S sub 2 and S sub 3. But that doesn't make sense on further analysis. Once again, consider transitivity. Because if S sub 1 equals S sub 2 and S sub 1 equals S sub 3, then it would logically follow by transitivity that S sub 2 equals S sub 3. But how can that be? How can the two ships, the two distinct ships, be identical? So this raises a new principle. We have to go back to the great mathematician and philosopher and logician, Gottfried Wilhelm Leibniz. And we're thinking about Leibniz's law, or the indiscernibility of identicals. If one thing has something that another thing lacks, then it follows they cannot be identical. They cannot be the same thing. These ships are at two different places in space. Moreover, they're made out of different material. Therefore, they cannot be identical. Now, we can think about Leibniz's law with modal logic and so-called second-order predicate logic. So let's think about Leibniz's law. So we'll say that box for necessary for all x, for all y, for all f, if x is an f and y is not an f, then x cannot be identical to y. So it's necessarily the case that for all x, for all y, for all f, If x is an f and y is not an f, then x and y are not equivalent. They're not identical. And speaking of logic for a moment, notice that the quantifier is with f, not just for x and y. So in first order predicate logic, we have quantifiers for objects, though in second order predicate logic, we have quantifiers for attributes. And to express Leibniz's law precisely, we thereby utilized modal logic with our box of necessity and also second order predicate logic. So because we can rule out that S sub 2 is equal to S sub 3 by Leibniz's law, we've run into some issues here. What can we make out of this puzzle? To be sure, we could claim that the original ship is not identical to either of the two. Nevertheless, that doesn't seem like a totally fulfilling answer. So clearly, isn't it the case that S sub 1, for example, equals or is identical with S sub 1 prime? Perhaps despite Leibniz's law, we can have situations where one thing is at two places at once, for example. That's not outright contradicted to logic. It's not technically a violation of the law of contradiction. But on the other hand, clearly S sub 2 and S sub 3 are made out of different material, so how can they be the same thing? Now, a ship, metaphysically speaking, ontologically speaking, is an artifact. It's not a substance. That is composed of substances that stand on their own, and they're being unified together to create this ship. There's a certain vagueness involved, it seems, of what it is to be a complex artifact. But vagueness, for example, is not ambiguity, per se. Ambiguity is a lack of one meaning. Vagueness is rather a lack of precise meaning. We have this idea of a ship. That's not vague. The ship either sinks or it doesn't, right? Yet perhaps in this dividing of the ship, where we're replacing planks, there is a certain kind of vagueness. When is a ship, so to speak, not a ship or not the same ship any longer? In any case, I think we should try to think about common sense here as best as possible. For example, consider this. In the more normal situation, if you take my car's wheel, hopefully by voluntary agreement and not theft, and it becomes a wheel in your car, then that part that was once of my car no longer is. It's not part of mine anymore. It obviously was, but it no longer is. So perhaps if all the parts of the ship were reassembled to compose a new ship, S sub 3, it's a different ship. It's a new one, even if the parts that formed it were once a part of the original ship. Another issue we can raise is intermittent existence. Is such a thing possible? Can something have an interrupted existence? That's an interesting question too. To exist is to be, so to speak. It's to carry on, carry forward in a state of being, in a state of existence. Now, how we think about this and what the actual facts of the matter are on these various sub-issues will, of course, affect how we answer this puzzle, which we haven't solved, but you can see it's more complicated than one might think once we consider the logic of equivalency. Now, I hope this video has whet your appetite to think about such philosophical puzzles and how we could apply logic to try to think about them more clearly and perhaps come to a solution, or at least attempt to come to a solution. Well, I hope you enjoyed this video. If you did, please consider both giving this video a like and buying me a cup of coffee. Additionally, I hope you check out my website, amateurlogician.com. There you will find an extensive tutorial on traditional verbal style logic. There are many article entries that cover everything from logical fallacies to logical dilemmas to the laws of thought and much, much more. It will help anyone increase their logical thinking and reasoning skills. It'll help anyone analyze arguments, spot fallacies, and even debate. And if you benefit from that tutorial, consider supporting my work. Join the community, so to speak. Keep a lookout for a new logic course in the future and much more. Thank you for your viewership and support. And if you have any questions or suggestions, please let me know in the comment section below. I would appreciate that. Good luck to you and be well.